guys. So today we are going to be talking about transformations. Now this stuff, again, today is going to be so important, and this stuff is going to be something that you're going to continue to use throughout math. So I would suggest you really take some time to learn it now. I will tell you, it's not going to come easily. It's going to be something that you really need to practice at, but then once you get it, you'll be golden. So I would suggest to just go ahead and take some extra time, maybe do some extra problems to get to know what is going on here so that it can come easily as we continue on. All right. So it talks about in an algebraic or analytic method can be used to determine the domain and range of a transformed function without graphing. Okay, so let's just say we've got a domain of -3, 3. Okay, so our domain is going to be -3, 3. Yes, it's including that, so I'm going to put in brackets. And our range is 0 to 3. So here's our domain and here's our range. Look at the transformation and the resulting domain and range for each of the previous questions using the patterns. So we're just looking at patterns, and we're going to talk about that. So this is so important, and then you're going to have a quiz on this. So if we've got a function like this, this is saying it's moving right 10 units. Okay, how do I know that? Because the negative, remember, if it's in the parentheses, it's the opposite. If it is, so it's going to be, instead of going to the negative side, it's actually going to the positive side. This is a horizontal shift. Right, okay. So when you have a horizontal shift, you've got your X and your Y. What that's going to do is that's going to actually change your domain. The range is going to stay the same. So my domain is actually going to change by 10. So I'm going to take my domain and I'm just going to say, if it's going to the right 10, then that is going to be, I'm adding 10 to the X value, and I'm adding 10 to the low value, and I'm adding 10 to the high value. These aren't X and Y, these are low and high. So now my domain would then be 7 and 13, because it would have shifted over 10 to the right. All right, but what happened to my range? Well, there's no changing to the range, and I'll explain to you how you can see that. But as of right now, the range has not changed, so we're good with the range. What about this one? Well, now the range has changed, and the way that you can tell is when it's in the parentheses. When it's in the parentheses, that is a domain change. That's a change in the domain. That delta means domain change. The little triangle is called a delta. That means change. If it's outside of the parentheses, then that is going to be a change in the range. Okay, so keep that little tool in mind. So this is outside the parentheses, the outside of the functions. So we're going to have that be a change in our range, and that is actually moving down 10. So that would be subtracting 10. So my domain doesn't change, right? I haven't done anything to my domain. However, my range has changed. So I've gone from 0, and I'm subtracting 10 from that value. And I'm subtracting 10 from the high value. So I would get -10, -7. So this would be my new range right here. Okay, and if you want to check it out, I would highly recommend you go to Desmos and you just plug in f of x or y equals x squared, and then change it around like this and see if it matches. All right, so now I've got this, again, is outside the parentheses, so this is going to be a change to my range. Oh, this is a vertical shift, sorry. Vertical shift down 10. This is going to be a vertical stretch by a factor of 10. That's the number right there. So again, my domain has not changed. My domain has stayed the same. My range is going to change. And how to change my range? Well, I'm multiplying. So I'm going to take my original range of 0 and I'm going to multiply it by 10. And my original high value of my range of 3, and I'm going to multiply that by 10. So my new range is going to be 0, 30. Because this has lengthened it. Moving on. This, however, is inside the parentheses, so this is going to be a change in my domain. All right? This is going to be a change in my domain. Now, this is going to be a horizontal. Get this. Remember we talked about how the parentheses lie. So whenever it's in the parentheses, it's going to be a little bit of a problem. This is actually a horizontal compression. It's the opposite. So when the number is bigger than, when the change in the number is larger than 1, then it's a compression. So we're going, and what we're going to do is instead of multiplying it by 10, we're going to actually multiply it by 1/10. I know. So up here, we like it when it's outside the parentheses. When it's inside the parentheses, it gives us all sorts of problems. So we're going to take our domain, our original domain, and multiply it by 1/10. So we're taking our low value and our high value and multiplying it by 1/10. Then I'm going to get negative 3 over 10 is my low value for my domain. 3 over 10 is my high value for my domain. My range has not changed. All right, so this is going to stay at 0, 3. All right, so now we've got something that looks like this, where we're going to change the range with the outside number. So that's going to change the range by a factor of, so this is a vertical compression because it's less than 1 by a factor of 1/6. And then it's a shift in the domain because it is a translation where it's moving left 17. So how does this affect? So both our domain and our range is going to be shifted. So we know that when we have it in the parentheses here, if we go back up to this, we're going to basically subtract from our domain negative 3. We're going to subtract 17, right? Because we're doing the opposite. If it's plus, we're subtracting. If it's minus, then we're adding. And so we get for our domain, we get negative 20 and negative 14. Oops. And then for our range, we know that when we have a number on the outside, whether it's a compression or a stretch, we're going to multiply our range by that factor. So we're going to multiply it by 1/6. Now, keep in mind, if it was horizontal, we would flip it, but use the reciprocal, but since, or we would divide by it, but since it's a vertical, we're just going to multiply. So then we take 3 times 1/6. 0 times 1/6 is 0. 3 times 1/6 is going to give us 1/2. So both our domain and our range have changed. Moving on, now look at this. So we've got two situations. We've got a vertical shift up by B, and we've got a horizontal shift to the left by A, okay? So our domain, which was originally negative 3, 3, I'm going to write that down here. Our domain was originally negative 3, 3, and our range was originally 0, 3. We're going to take the negative 3, and since we're going left, we're going to subtract A, and the positive 3, and that's it. That's our new domain. We can't really give you numbers because it's going by a variable that we don't know the answer to. But it'll work for no matter what we do. And then we've got a vertical shift, so our range is going to go from 0, and we're going to go add B, and then 3 plus B. So our range is just going to be B, 3 plus B. All right, so that's how you figure that out. Now, what about this? We also have two shifts. This is going to be our vertical shift, so that will change our range. This is going to be our horizontal shift, so that's going to change our domain. This is going to change our range. And we are going to take the domain. Now, remember, our original domain is negative 3, 3. And we do it by the reciprocal. So we're going to multiply negative 3 by the reciprocal of D, or same as dividing it. We would divide it. And then we get our other one, times 1 over D. So that would be our new range, or you could rewrite our domain. I'm sorry, we could rewrite that as negative 3D, 3D. And then for our range, we're going to actually multiply it by C. So we're going to start off with 0 times C for that side, and then for our low value, and then 3 times C for our high value. So we would be left with 0, 3C. And that's our new range. All right. So flip to the back of this page, and I'm just going to give you a little bit of a cheat sheet. So I just kind of want to give you a quick cheat sheet on function notation and how you would know. So this is just a blank page. You're just going to write this all out. So if you have f of x plus d, okay, this is a vertical transformation by d, right? That is going to change your x, y. If this is your original point, that's going to change the range, right? Because it's outside of the parentheses. So I'm going to write that in a minute. To x, y plus d. All right? So remember, if it's inside the function, or the parentheses, it'll be a change in the domain. If it's outside the function, then it is going to be a change in the range. So really pay attention. So let's see. So if I have f of x minus d, that is going to change the xy in the sense of it'll be x, y minus d. This is going to be a little cheat sheet chart, okay? So there are your vertical transformations. Now we've got our horizontal transformations. So we've got x plus c. This is going to be a horizontal transformation. The plus c, remember, is going to go to the left. The minus c is going to go to the right. So your point x, y with a plus c would actually be x minus c, the y, the range hasn't changed. If it is f x minus c, then your low and your high would change x plus c. All right. Now keep in mind these are original points. All right, not domain and ranges. So next would be, so these are horizontal shifts. Now if we do a reflection, the negative f of x, now keep in mind that's outside the range. This is going to be a change in your, change in your range. This is a reflection over the x-axis. Sorry. And so your x, y is going to, basically your y is going to become negative. So your x stays the same. Remember, we're changing the range. The y just becomes negative. Then if we have f of negative x, this would be a change in your domain. It's a reflection over the y-axis. So x, y would become negative x, y. All right. And, well, let's just keep, well, so let me give you an example. So if we have, for an example, a point that is 2, 4, if I have negative f of x, that point is going to change to negative 4. If I have f of negative x, that point would change to negative 2, positive 4. All right? That's just an example of how these change. All right? Now, let's talk about our stretches and stretch and compressions. All right, so now keep in mind the vertical and the horizontal are going to kind of be opposite. So if I have a f of x, where a is a number, so this would be like 2 f of x, like that. When the a value is greater than 1, it is going to be a stretch. When the a value is between 0 and 1, it's going to be a compression in this situation. Okay, these are vertical. Makes a huge difference because in these our range is changing. Okay. So, given a vertical stretch, we are going to see x, y, and how that changes is you multiply. So, x, and then you just multiply whatever that is. So, in this situation, x, y would become x, 2y. All right? In a horizontal, when you have f of ax, this is a horizontal, stretch is actually where it goes 0. So let's change this to b. Let's change that to a b so we're not using the same variable. To 1. And a compression is where it is greater than 1. So if we have, for an example, 2x, f of 2x, like this, then our x, y would be changed, and we are going to multiply by the reciprocal. We are actually going to divide by b. All right? So basically that would be, for an example in this situation, x, y would become x divided by 2 over y. And keep in mind, if we have x 1/3 x, this x, y, when you divide by a fraction, remember, it becomes you basically are multiplying. So keep in mind that this, okay, so this is where it starts to get just a little bit confusing, but I think you can get it. All right, that's it. Hope this is helpful.